Hello everyone, I am Dr. J. Dhanalakshmi, Assistant Professor, Department of Chemistry, Kamaraj College of Engineering and Technology. Now we are going to discuss about classification of corrosion. Based on the environment, corrosion is classified into two types. Before that, corrosion, what do you mean by the term corrosion? The gradual destructions of the metal when it is exposed into the environment. Already we have discussed what is corrosion, what are the factors which influence the rate of corrosion and how corrosion occurs, right? Now we are going to discuss about the classification. So based on the environment, corrosion is classified into two types. The first type is dry corrosion, or otherwise call it as chemical corrosion. The second type is wet corrosion or electrochemical corrosion. In this session, we are going to focus the first type, dry corrosion. Dry corrosion. Dry, that is absence of moisture. Due to the attack of a metal surface by the atmospheric gases, the corrosion occurs. This is called dry corrosion. Now we will see about the mechanism of dry corrosion. The first step, see, it is a metal. This metal surface, it is exposed into the environment. It interact with the environment gases. So initially the metal is going to convert into the metal ions and loss of electrons occurs. This process we call it as oxidation. This is the first step. The metal surface first convert into the ionic state. At the second stage, oxygen present in the environment accepts the electron released from the metal surface and it gets reduced into O2 minus. This is called reduction, right? So metal get oxidized and convert into metallic ion, and oxygen from the environment accepts the electrons and get reduced into ionic form. As a result, the ionic form of oxygens and the metal ions combine together to form MO, metal oxide. So this is the basic mechanism of dry corrosion. And coming to the types of corrosion. There are three types of corrosion. One is corrosion by oxygen, second type is corrosion by hydrogen, third type is liquid metal corrosion. Let's see one by one. Corrosion by oxygen. So the direct attack of oxygen on the metal surface. Consider this is a metal surface. The direct attack of oxygen on the metal surface in the absence of moisture, that is called as corrosion by oxygen. Even at low temperature, all alkaline earth metals are rapidly oxidized, and at high temperature all the metals get oxidized except noble metals, because noble metals are corrosion resistant. And see the mechanism of oxidation corrosion. Look at the picture. So this is a metal surface, the whole metal surface, this portion is get exposed into the environment. So this line, it is metal oxide interface line. So metal is exposed into the environment. It is react with the oxygen present in the air. So now the metal, this metal convert into metallic ions M2 plus and loss of electron occurs. This electron is accepted by the oxygen present in the environment and get converted into ionic forms. That is, oxygen get reduced and metal get converted into ionic form, and both this metal 2 plus and oxygen 2 plus is combines to convert into MO, forms a metallic oxides. This is the mechanism of oxidation corrosion. And as a result of the corrosion, different layers are formed. The layers plays a vital role in the oxidation corrosion. See, there are 4 different types of layers are formed. The first layer is stable oxide layer, second one is unstable oxide layer, and third one is volatile oxide layer, and fourth one productive or non-productive oxide film is formed. The first layer, stable oxide film or layer. Metals exposed to the environment, the oxygen or gases attacks on the metal surface, where the adsorbed tightly, that is, the film formed on the metal surface, is adsorbed tightly on the metal surface. So that type of layer we call it as stable oxide layer. This stable oxide layer always behaves like a protective coating. If it is act as a protective coating, there is no further corrosion will occurs. Yes, there is no further corrosion occurs or can develop on the metal surface. All the metals exposed into the environment, corrosion, the stable oxide films occurs, particularly copper and tin, aluminum and lead metals exposed to the environment, the stable oxide layer is formed. And move on to the second layer, unstable oxide film or layer is formed. Look at the picture. So look at this portion. So this is MO, that is oxide films, oxides formed on the metal surface. What happened? The surface of the noble metals, actually it is made by the silver, it is noble metal. All the noble metals won't get corroded because it won't react with the environmental gases or anything else, because it's highly resistive. But it forms a layers, but the formed layer on the surfaces, it is decomposes back immediately. Once the metal is exposed into the environment, it combines with the oxygen and immediately it go back to the metal oxide layer. That is, it is reversible processes occurs. So it is not tightly held on the surface, so that it decomposes back into the original state. Now move on the third layer, volatile oxide layer. See, volatile means it is volatilized, that is, for example, we have solutions, liquids, it is alcohols, it is exposed into the normal ordinary temperature, the gases get volatilized. We call it as volatilized as soon as it's formed, leaving the metal surface, right? Now look at the picture. This is called it as molybdenum metal. Molybdenum metal get oxidized and convert into the oxide forms of molybdenum. So oxide film is formed on the metal surface. Top surface convert into the oxide forms. After that, the oxide form of MoO3, molybdenum oxides, in presence of thionyl chlorides, it is again go back to the metallic state. The layer is volatilized. So only the metal surface is exposed. That means the volatilized as soon as it formed and leave the metal surface for further corrosion. So this is for the third oxide layer is formed. And fourth one, it is depending on the ratio between the volume of metal oxide to that of volume of metal consumed. So, this ratio we call it as spilling bedworth rule or ratio. So, the ratio of the volume of the metal oxide formed to that of metal consumed. Right. According to this rule, there is a condition. Yes, if the oxide film layer formed is lesser than the volume of the metal, in that case layer is formed, that layer is porous in nature. See, a metal have a pores in nature means there is a further corrosion occurs, there is a possibility of further corrosion. So, if the oxide layer formed is lesser than the volume of the metal, the layer is porous and non-productive and the further corrosion occurs and metal is completely destruction. And if the reverse case, it is greater, that is the oxide layer formed is greater than the volume of the metal, in that case the layer is not having any pores, it is non-porous. There is no pores on the metal surface means it is completely covered. It is completely covered, the top surface of the metal means it is act as a protective layer. So, there is no further corrosion will occurs. All the heavy metals, it is under this category, the protective film is formed. And alkaline and alkaline earth metals or produce a pores in nature and protective layers formed on the surface. And the second type, corrosion by hydrogen. So, look at the reaction first and we will discuss later, rest of things we will discuss later. So, this is a metal surface made up of iron. Atmospheric gases have hydrogen sulphide. It is reacts with the Fe, so get converted into FeS, and this is the atomic hydrogen is released. This atomic hydrogen and recombines and convert into hydrogen gas. So, once the gas, hydrogen gas is evolved, it creates voids. So, that develops very high pressure on the metal surface. As a result, metals, the creations of the high pressure due to the excess of hydrogen in the metal surface, a crack may occur on the surface. So, this crack or blisters means the minute hair cracks on the metal surface. The blisters on the metal surface, we call it as hydrogen embrittlement. Brittlement means crack or blisters on the metal surface. And coming to the second type, decarburization. What happened? Already environment have a hydrogen gas, it get dissociate into the atomic hydrogen. How it get dissociate? By thermal decomposition. So, at high temperature, thermal decomposition occurs. So, this hydrogen get dissociate and convert into atomic hydrogen. If the environment having the steel, particularly carbon steels present in the environment, this hydrogen, atomic hydrogens as combines with the carbon steel. So, carbon steel have a ion with a carbon. So, now the atomic hydrogen reacts with the carbon and converted into methane gas, it produces methane gas. So, it is exposed to the environment, the readily atomic hydrogen is combines and produce methane gas. As a result, cracks or blisters occurs on the surface of the metal surface. So, the process of decrease in the carbon content in the metal, carbon steel metal, that is called as decarburization of steel. And hydrogen embrittlement means due to the hydrogen gas in the surface of the metal surface at high pressure, it leads to the cracks on the metal surface. This is called as hydrogen embrittlement. And the third type is liquid metal corrosion. It is very simple technique, just by action of liquid metal. Action of liquid metal at a high temperature. Either liquid metal means like mercury, it is a metal, liquid metal. So, the dissolution of a metal by a liquid or the metal, liquid metal may penetrate into the solid. For example, a copper metal, consider a copper metal. The copper metal are susceptible to liquid, that is, it is combines or affected by the liquid mercury and cracking is occurs. This is called as a liquid metal corrosion. So, not only the solid metals and also liquid metal corrosion also occurs. So, these are the types of corrosion. So, in this session we have covered what is dry corrosion, what is the mechanism of dry corrosion, and what are the different types of dry corrosion. That is all about the dry corrosion. Thank you.